Welcome everyone to another episode of the Platformers. We have in with us Mike Torganon from Adobe. I think I'll let him introduce himself. Right, Mike?
Yeah, hi. I'm Mike Tugeron. I'm a lead cloud engineer slash the platform infrastructure architect at Adobe. Been working with Kubernetes since forever at this point. Thanks for having me on the show today. I appreciate it.
Welcome, Mike. And yeah, today I invited Mike to talk to us about Kubernetes fleet management. A lot of folks ask me in at work and also at conferences like KubeCon, and Mike have talked in many conferences in KubeCon in the EU and North America, and the next one will be in London. I'm planning to be there. I don't know, Mike will be there.
Yep.
Um, and the thing that we're going to discuss today is a very cool project. I'm wearing the T-shirt Argo, so we're talking about Argo and GitOps. In general, a lot of people ask, "Can you do fleet management? Can you manage large amount of EKS clusters with GitOps?" And my answer is yes, you can. You can actually look online for some of the talks from Adobe in GitOpsCon, KubeCon, and also Adobe is part of the Canoe project, the Cloud Native Operation Excellence project that Adobe is part of it, and AWS that I work with is part of it, and many other companies trying to build platforms, internal developer platforms using Kubernetes APIs. And since we're using Kubernetes APIs, the most the most common way that people use Kubernetes APIs is through GitOps. Basically, that's the source of truth. And a lot of people use it for applications, but not a lot of people know that you can actually create the Kubernetes cluster from Kubernetes cluster. That's the kind of deception, and kind of like the half joke of the Capi project, the cluster API project of like using Kubernetes to create Kubernetes, and that Kubernetes create another Kubernetes, and down it goes. So Mike is an expert on Capi and actually a contributor, right, Mike?
Yes. And that like you were saying, it's turtles all the way down. I believe is the saying that community uses. So.
Yep. So let's move on and explain like when we say large amount of clusters, what we are talking about.
Yeah, so this is kind of the brag sheet for Adobe's Kubernetes, but the point that's really the brag sheet on it is the last bullet point there. We do this almost entirely with open source tools and concepts. Um, like the system components and add-on deployment system. There's maybe 300 lines of custom Go or Python code that runs it for all of this. It's we haven't written a lot. It's all Argo, Helm, and Kubernetes stuff like that. We didn't have to write a lot of code in order to manage a fleet of this size. So the stuff that people are able to do for one cluster or two clusters is able to scale up to Adobe size at 400 clusters with petabytes of memory and a million CPU. So it's really quite impressive what open source can do for us.
And I see there you mentioned also cloud providers, AWS, Azure, and private data centers. So it looks like you
Mm-hmm.
are managing everything through GitOps, even if you're using multi-cloud.
Yep.
And talking about GitOps, a lot of people use Terraform, right, to create the networking layer where you put your clusters, also to define the clusters, define the nodes. Terraform is very popular, and a lot of folks always ask me, can I replace Terraform with GitOps? Can I use YAML files or a declarative way of doing that? Terraform works. A lot of people make a lot of success with that. But I think in Adobe, you made a decision of saying, let's do an experiment. Let's try to do everything with GitOps at our scale to see if it works. So tell us about GitOps.
Yeah, so I think GitOps really matters for infrastructure, just like it matters for application developers, because infrastructure is a type of application. These days with cloud-based infrastructure being APIs, an application that delivers some sort of feature to a website is API driven. Even bare metal data centers, the way that you manage those bare metal data centers are through some sort of API. You're not typing in code and committing things to your systems. There's APIs that manage those things. So everything boils down to an API these days. And being able to store that as that source of truth, being able to do some sort of GitOps deployment for those systems, be it cloud or data center, uh, just gives you that increased velocity and reliability. So we really believe that GitOps, as it says down there with the meme, it is inevitable. Everybody will be using it at some point.
And
But
skills matters, right? Your team, you don't have a very large team, so if everyone is familiar with Kubernetes, they know about Kubernetes APIs, they know how to authenticate, they know how to like configure resources, they know how to like configure the applications. The applications are most likely going to be GitOps. Then controllers are the thing that you're more familiar. Even creating controllers yourself, your team, right?
correct, yeah, and so that's the thing is, I put the nice star here on the cloud agnostic side because nothing's truly cloud agnostic. But like you said, we deploy to multiple cluster types, multiple cloud providers, but we do it in a familiar feeling way, not just between those cloud providers, but just like we were to deploy any other standard application, using a Helm chart, using templating, we're able to create our cloud resources. We're able to, using the ACK and ASO, we're able to create clusters using the cluster API, custom operator. We're able to use things like Carpenter to manage the nodes. And then, we get onto the clusters themselves, external secrets operator, Prometheus operator, cert manager, gatekeeper, the list goes on and on and on of these controllers that provide features, not just on the management clusters, but on the clusters themselves that take the complexity and custom code out of our hands and into the community and the open source best practices across the board. And then we again use these controllers like Prow, Argo CD, Argo workflows to help manage and orchestrate these deployment practices across the board from testing to deployment all the way through the pipeline to make it entirely an open source process.
And I see you mentioned Carpenter is a node auto scaling. It's a way of like I guess it's maybe the next generation of a cluster auto scaler. But how was your transition from? I'm guessing that you were creating managed node groups with cluster APIs, like creating nodes with cluster API, and then now some of those clusters you start adopting them to Carpenter, and the Carpenter's now like the one like is configuring those nodes.
So actually, Carpenter, we implemented Carpenter prior to implementing Cluster API. So that actually made the transition to Cluster API a lot easier. You may have noticed on one of the previous slides, we actually run a combination of Flatpak and Ubuntu for our operating system. And so what's really interesting with that is Carpenter allows us to easily run more than one operating system through those node pool definitions that Carpenter allows. Where that makes it really easy with Cluster API is that we create the Cluster API to manage the cluster and a kind of a system node pool, cluster pool using with EKS the managed node groups or with AKS its equivalent. But then Carpenter handles the standard compute tiers depending upon the OS type for what the people on the clusters need to use. And it's a Helm chart that deploys it. And it made the transition from more of a self-managed node pool or node group approach and the different auto scaling groups and stuff like that to this GitOps controller driven approach a lot easier to have that done in the first place.
But all these components are YAML files that sit in Git. Even ACK and Azure ASO are like YAML files that then GitOps would take and apply to the, I guess you have a management or control plane cluster, like your mothership, I can say.
Yes, more than one of them. Separations, concerns, stability, security, all that kind of stuff. But yes, like I said, we have very little custom code that runs this. Everything, almost everything is Helm templates. People joke with Kubernetes about, you become nothing but a YAML wrangler and do nothing but YAML code. Our team is turning into basically a team of people that write YAML and contribute to open source. And that's how we need to do business now. And the YAML is Helm templates for us, and that templating is more, configuration of how we want things to be defined, what's the state of the world as we want it, and then the contributing to open source is to either make it more scalable, more feature rich for the community, or just helping, the community in general. But there isn't something that is Adobe specific in the functionality of these systems.
And talking about YAML files, let's move on the Git repositories. I'm guessing you have one monolith. You have everything in one repo that everybody fights over, like which YAML files do they change in one folder, or do you have a structure to
Wouldn't
deal with this?
that would actually be, in some ways simple and complicated. But for our Kubernetes cluster management, we have over 320 different repositories. That sounds really complicated, but we use a tool called Prow that was set up from the Kubernetes upstream. It again allows us to manage our repositories back to GitOps in a declarative GitOps driven fashion. So we have some config files that we manage in one repo. It gets applied via Helm chart once again. Prow then picks up that configuration and then manages the repos. We do have a couple of minor plugins. That's just to give it a little bit of extra flavor and fun than necessarily, core functionality. But it does everything from PR lifecycle to execution of our CI jobs and post processing for creating container images, packaging of Helm charts, and we do some other, business metadata type stuff that is Adobe specific, but not for running our fleet, but more, the enterprise system stuff that we have to do. Prow allows
And
us. Oh, sorry. Go
I
ahead.
have one question about the GitOps repo. You have a 320 repos. Are those are they categorized between, like in GitOps? Usually, when people start, I usually give them a guidance, and this is also comes from the GitOps community and books like Christian Hernandez have wrote in a book of the GitOps path on separating the repo that has the Java code and the Gradle files, or maybe the npm and the Node.js, from another repo that has the configuration where this app gets deployed to different clusters. You follow that same paradigm, or every app has the source code and the GitOps configuration?
I would say about 280 of these repos are nothing but Helm charts, um,
Oh,
and that,
really?
and that's because they're either a cluster add-on, back to the Carpenter cluster autoscaler, Prometheus operator, these tools that we don't even write the code for, or they're the Helm chart for creating a VPC or a VNet or an S3 bucket or something of that nature. So we don't, it's not even something um, that we write application code for. Some of them are for repositories that are just documentation, sources of documentation that are used for our AI Slack bots for providing information, generative AI stuff to help support type tickets. Some of them are for, just don't even, they're just applications, Slack bots that provide, cluster management type stuff. And so there are applications that don't even run on the Kubernetes clusters that are in here. So it's any sort of thing. But for the most part, most of these are not even applications that we write um, ourselves. Like I said, open source across the board. For those that we do have custom code, they are, I would say 99.9% of the time separated between application code in one repo and the Helm manifests in a separate repo.
The Helm manifests the values the driving inputs, right? Live in a different repo, and the Helm source code is in this repo. So I imagine that do these 200 and something Helm charts are individual. It's like your GitOps modules, right? These are the components of your GitOps infrastructure. They're Helm repos. Do you deploy them directly as Helm and you version them at the repo, or you package them and put them in a Helm registry like an HTTP or OCI?
So in for our dev cluster, sandbox and dev clusters, we deploy directly from Git. But for all environments above that level, we deploy from a packaged Helm chart using Artifactory. But it would work with.
Artifactory meaning the HTTP format
I
that
believe,
has the index.yaml, right?
yeah, I believe it's the HTTP
Artifactory.
one. Though I can't remember for sure off the top of my head. It may be the
So
guy inside Artifactory or the HTTP, but yeah.
are we going to see a similar demo like this, right? Like where if somebody changes something to the Helm chart, it needs to be versioned, it needs
Hmm.
to be released, and then it needs to be rolled out across the different clusters, including starting from Sandbox Dev to the PIM version that you're using in how many, like you have hundreds of clusters, right?
Right.
Uh, if they make a common change on this Helm chart. So they move on to Prow, I don't know how to pronounce it, but for those that don't know, Prow is a open source utility, right? Open source project that is used in upstream Kubernetes and on some of many upstream Kubernetes projects of like managing PRs and issues with comments, right? Slash something. Can you show us a little bit of that?
Yeah, so here's just a very basic example of a PR. And we'll actually, I have a demo at the end that'll show this in action. But basically, you see here, here's just a quick PR. I give it a kind and tell it to hold. And Prow adds a label to hold, and gives it another label of release. It gives kind of the holy wall of text. Does a bunch of things. People can give it an LGTM. They can approve it, and then Prow will merge it once it has the LGTMs and approvals. So it manages the GitOps lifecycle. It can trigger tests and a bunch of assigning to people for reviews and a bunch of things like that. So it is very powerful. Think of it like a chat bot but for Git. You can assign different rules, labels, and a whole bunch of different stuff that you can do with it. It has a
Yeah,
lot.
take into account. Yeah, and take into account that Pro was created before GitHub Actions existed, right?
Uh-huh.
Was something that was created by the Kubernetes upstream project because it's at mass scale of so many people, so many PRs, so many subcomponents in one monorepo, right? You needed to have something like this. So we'll take a look at what it takes to create a PR and propagate it to that. But before that, like I'm Carlos, I come to Mike, and I want to create a Kubernetes cluster. How difficult it's for me to create a cluster with your system, like starting from like I want a Kubernetes that is 1.30 and it has certain characteristics and I need certain add-ons. How that workflow looks like.
Yeah, so the cluster workflow, it's 3 slides, so it looks kind of complicated. I'm going to go through this really quickly because diving into the details, this could be 4 hours of conversations. But it really just starts with a user commits a file to Git. If it's a
That
sandbox,
part's not complicated, right? The thing that we didn't make complicated was like Carlos coming, give me a YAML file. Then
yeah, you
then
can
go have your coffee. Once you have your coffee, your cluster will be created. That's the role of the platform team.
yeah, and you can do it via CLI, and the CLI commits it to Git, that kind of thing. But it really
Oh,
only
even
takes.
that, even easier.
Yeah, you can do it with it's the minimum I believe is like 3 or 4 params. And I mean, granted, that's not going to be a productionized cluster because production you always need more customs and tweaks and stuff like that. But it really starts that basic. Argo CD picks it up with a Git generator. It then launches things into the cloud, ACK controllers in the AWS situation, creates the resources that a cluster gets launched into. Um, there is a post sync hook that triggers commits back into Git with the IDs from this that triggers the cluster API build because the application set get generator detects new values that then launches your cluster API. That launches those things and then kicks into Carpenter and things like that. It then, after those things are created, there's an Argo workflow that in events that get triggered that watches for those things to be done. It then validates the build success and registers it back into what a different Argo CD. So we separate the Argo CDs between what does cluster build and what does system components or add-ons. That
So
then,
you have Argo apps for different components. So you have an Argo app. On the previous slide, you have an application set that creates Argo apps to create your base infrastructure, your subnets, your VPC, everything from the cloud provider. It could be Azure, it could be AWS, right? But it's just Argo apps that deploy Helm charts. Those Helm charts have the YAML files for ACK or ASO you mentioned, right? And then you're also leveraging Argo CD post hooks to say this stuff is done, move to the next stage in Argo to
yeah,
deploy the cluster.
correct. So this is all a Helm chart here. All these things are Helm charts, separate Helm charts to a great extent. Little bit of custom code here to
To
pull
extract the results, the IDs.
to extract the results, push it back to Git, and then back into Helm charts again to do the rest of this. Now this will go away sometime next year. We're waiting for some really cool tools coming out, like the Crow project, KRO, that was just released and announced by AWS. We have some really high hopes for that project that will help with some of this, but that's still in its
Yeah,
stage.
that's my team working on that, and this is actually working with Adobe is one of the customers that we came up with these requirements of, like, you need a dynamic way to compose kind of like the outputs of certain other resources to make to pass them to the next resource, right? And then do not create the next resource until you have the status of the previous one. So you can check it online, scroll.run, using CEL, Common Expression Language, like very simple schema of, like, I need the VPC ID and I need the subnet ID and I need these little small strings or arrays passed to Capi, right?
Right.
For Capi to do its work. So right now you're doing it with custom code that is technical depth that can go away and be done by a controller.
Yeah.
So the next stage was Argo workflows comes into the picture. So Argo, um, you deploy no, the previous one.
Oh,
So you deploy the Argo, the cluster, and these clusters get registered in your main system, right? They need to be observed.
mm-hmm.
You need to check for cloud resources. So it is, you create a cluster, but it needs to be part of the fleet, you can say, right? It's
Right.
not a managed cluster. It becomes a member of the fleet. That is enough add-ons to make it that it works, right? That it
Correct.
minimum MVP, and then make it part of the fleet, but it's not, you don't know the rest of the add-ons that are deployed next, right?
Right. Yeah. I mean, launching a Kubernetes cluster is great, but as most of you probably know, having Kubernetes as a bare bones Kubernetes, you can't do a lot with it. You don't really have ingress. You don't have auto scaling. You don't have, a network layer. You don't have a lot of stuff. And so that's what this next stage does. It looks to the definition that was created with Cluster API to get the different cluster attributes, to use that to register it into Argo CD with the appropriate labels and annotations when it registers it into these add-ons, Argo CDs. Once that's done, there's a whole bunch of syncs that get done. The kind of the more critical charts get synced, your CNIs, your DNS, your autoscaler, cert manager. I want to say maybe a dozen critical charts get synced first. And then when those are synced, essentially the rest of the world gets synced. This slide's a little
And
out of
I have
date.
a question. You mentioned something about putting metadata and labels in the somewhere, are you using application set? Are you using a cluster generator with that information
Yes.
in Argo CD?
Well, I'll get into that in a couple slides, but yes, we use app sets or application sets everywhere. We do everything as attribute-driven selectors. It's at our size. There's just basically no other way of doing it.
Because I see Server Manager needs some metadata and Carpenter needs some metadata. So that metadata needs to come from somewhere. People put it in Git and some people put it in a cluster seeker. So both are application sets driven, right?
So we do both actually. We have some, some of the values definitely come from Git, but we found that the vast majority of the values um, are calculatable, as in they're a combination of values. So it's a matter of, okay, it's the cluster name plus, an AWS region
Region. Yeah.
something.
I guess
And
we're
so
guessing
really we found it all really boils down to about 4 to 7 attributes of a
unique.
cluster that really define almost every value of a Helm chart. That's not just a same value for all 400 clusters. I mean, well, cloud
I
provider
see.
variations, of course. And so, we do set those sort of things and pass them into the Helm charts from the application set. Um, but for the vast majority of stuff, just using the default values for the Helm chart that we've defined for Adobe's values, or a cloud provider specific override. So Azure sets this and AWS sets this. Um, we don't have to set a lot of overrides on a per cluster basis. Uh, so that's been, we've actually found that to be a lot simpler than we had originally expected when we went into this project quite a while back.
I see. And Argo workflow is the end watcher of like, I'm not going to continue or go to the next stage until everything's ready.
So this is actually slightly out of date. So we're actually playing around more now with post-sync flows. Um, on this, I didn't have time to recreate our entire flow diagrams, but we're looking more into the post-sync hooks because those are a little more reliable on when they get triggered and get re-triggered. Argo events, we were having some trouble getting them to trigger exactly when we wanted them triggered at the end of the sync versus potentially getting triggered a little bit before the end of the sync. So we had to fiddle with that a little bit, and we're finding that the post syncs are happening a little bit more reliably for what we needed. It's not that the Argo events and Argo workflow triggering isn't reliable, it's just that it wasn't happening at the exact moment we wanted them to happen. So
So now
we're
you have a more distributed model. You have a more distributed model that every Argo app has a little snippet of a post sync to do its work at that stage.
yeah, we'll talk about that a little bit too in about 3 or 4 slides. So,
Okay.
but yeah, basically all that goes through, and then things basically become ready for usage. And there's a final step that registers it into. We have an entirely separate system that our tenants that run on these clusters use to register those tenant applications, the ones that serve for Adobe's clients, that are different from what manage the clusters themselves, and that's done for a lot of different reasons. That I believe you had Vikram on a session a couple of
Yeah,
months
we have
back.
Baker and Pedri here talking about Flex, and they mentioned your team, and that's why we wanted to have you here
Yeah.
on like what's the team that creates these clusters for them to take it to the next stage, right? To provide the UI and the backstage that people can developers, thousands of developers can use to deploy to this cluster. So your team is the beginning of that cluster creation.
Yep. So just we're not planning on going through this, but I just basically wanted to show that creating a cluster with Cluster API is just basically YAML and a Helm chart. the node pools with cluster API on the left and Carpenter on the right. Again, it's just a YAML template coming from Helm, passing those things through. So it is all attribute driven. Most of these, as I said, are defaults coming from the Helm chart, but there are some cluster specific overrides. But for the vast majority of our stuff, it's pretty cookie cutter. The way I describe it is it's cookie cutter, but some cookies have sprinkles, some cookies have chocolate chips, some cookies have nuts, but they're all cookies. So it flows together pretty well with that. Upgrades, there's not a lot to talk about this except for this tool we use called Case Shredder. This is a really cool open source tool that we've released. It's one of the few tools that our team has written that we've open sourced that I would call our custom code, but we do open source it. It's kind of, for those of you that run on AWS, you may be familiar with the way AWS will send you a notification if a VM has a problem and you have so many days to do something about it before AWS basically has to shut down that VM. We do the same sort of concept with our nodes, that if for some reason a PDB doesn't allow us to evict all the pods on the node, we do what we call parking of the node. We label all the pods and provide notifications via metrics and those labels to the different people running on that particular node, that they have any number of days, or more specifically timestamp based, of when we will force delete that node, and they can self-evict or self-move around their workloads, so that we do that. So eventually, all the old nodes will be replaced because Case Shredder will forcefully evict those after that period of time. But that's kind of our way of getting around the non-evictable PDBs and stuff like that. We basically say, hey, you got 7 days, 14 days to do something about this because we have to replace this node due to a CVE or due to a Kubernetes version upgrade that we have to do at this point due to compliance or what have you. It's a really nice pattern that I find very useful, and I from what I've been seeing, cloud providers are going to be starting to adopt this same sort of pattern in the coming year or so.
Grace period, and then but we have to rotate that node because there might be a CVE patch, right, that we need to patch
Exactly.
on these nodes, and it's a grace period that you're given a chance. That's great.
Yeah.
So let's move to the Argo CD system on how you're breaking this. I'm guessing one Argo CD cannot manage that many applications and clusters, right?
No, so we actually have several dozen Argo CD instances that manage all of these clusters. This is just an example of the screenshot is of one of the Argo CDs for our stage environments. The key thing here, and I mentioned this, is everything is attribute driven. We never target a specific cluster. We always target an attribute of a cluster. So even if we're only targeting to a single cluster or two clusters, we still define that as an attribute and we target that. Um, it makes it a lot easier if attributes ever change or a new thing comes into it. We don't have to go back and say, oh, we need to say in this, and now this. We just add that label to the cluster, and the cluster selectors take care of it. And the reason for that is, again, back to the size. The cookie cutter thing only goes so far, but when you start looking into all the different variations of things that are into there, there are just hundreds of thousands of potential combinations of what goes into there. 400 clusters, 240 add-ons, cluster types, business units that have different qualifications, significant attributes, not just the minor attributes, different Kubernetes versions, all that kind of stuff. We have running right now about 55,000 different Argo CD applications after all these combinations are said and done. And so testing and validation has to be automated. There's just no way a human could test and validate it all themselves. It's just impossible.
And the different types you mentioned is for people that are getting started in Argo CD and multi-cluster is that you label the cluster, right? And based on the label, using application sets of saying, well, this Argo CD app needs to be get deployed to this cluster because it has this label, right?
Correct. Yeah. So when it comes to like a CI type environment, we label things with an app, with the app name as part of the PR generation. And we do a testing of that. Um, and then we set the revision of the chart that's being deployed. Um, but what's interesting is we do the same thing for production and stage. It's all part of the same app set. And so what you can see here is in the environment prod using that label selector, and the maintenance group is a canary prod group. It's defined to version 0.3.8, and the prod maintenance group A is 0.3.5. That basically means that this application has not been promoted to this version in maintenance group A yet. And down here in this target revision thing, it will use that version if it's set. And so that's how we promote different versions across different environments and maintenance groups across that fleet of 400 clusters. It allows us to keep a consistent deployment approach and just iterate versions. And then we have a CLI tool that updates those versions and promotes it across the environment.
And a little secret about this is I remember you giving a talk was a few years ago. And this is the basis of the GitOps bridge that I created at work.
Yeah.
Because this is where I learned that you can have logic, that section on the top and bottom is this is where I learned that you can have logic inside application sets. I thought everything was just values, but when I saw an if equals and like, can you have logic? And basically this is Go templating, right? So you are enabling the Go templating and you can have more logic inside these application sets. Because application set give you the ability of like the match selector of like if this conditions use this version, for example, on this condition use this version, or this condition just deploy the app. But also you can have the if statement of like massaging even more the end result.
Yeah, you got to be careful. You can really screw something up. If you get a typo in that if condition, it will
They're
affect.
very difficult to test.
Yeah,
Yeah,
but
I wish the Argo project maybe we come up with something that can like a dry run or an environment or a debugger or something because it's very tedious to come up with this thing. So you have to do it. I usually use a can cluster like in my computer to test this logic before I even put it in the share environment.
yeah. So we talked briefly about the posting hooks. I don't like using, people sometimes use these to manipulate things, create a secret or, stuff like that. I don't like using pre and posting hooks for that type of stuff, but I do think that they're good for what we use them for. Some large companies, you need to have like a change management system. So we use a pre-sync hook to record a change into that, enterprisey change management system. That's a good, thing. It doesn't actually affect the deployment, but we need to run it before every deployment just so that the enterprise compliance team is happy. And then as a posting hook, which is what is really interesting, kind of unique about our system, is we do this metrics test runner, and we do this after every deployment happens. And this is how we test our applications. Um, what this runner does is all about metrics determining the behavior of the application. And this is a kind of a unique way of looking at it. Since we don't write the applications, we don't run the unit tests. We don't determine how those things are there. All we have from these applications are the metrics they emit via Prometheus and how are they running and performing on the system. And so we already do alerting on these systems based upon those metrics. But we also take it to the next level and say, okay, well, there are some metrics that we think maybe something's not working, but they're not to the point of the system is down, but it may be not working quite right. And so we use that to kind of set up a integration test sort of situation. So in this first example here of one of these ones, if pod logs are not being sent, it's an integration test. But if audit logs are not being sent, it's a pageable offense. And so what this pod logs could be is like, oh, if the cluster autoscaler logs aren't being sent, okay, yeah, you know what? I'm not going to wake somebody up in the middle of the night for that. But if the audit logs aren't being sent, well, that could be a potential security problem, a compliance problem. So that is a more severe. But what will happen is this post sync hook will fail if either of these two metrics are being evaluated to true. And so what will happen is the Argo CD job will fail, the sync job, which will then trigger an Argo CD notification to Slack or to a webhook or to wherever you want it to go to say this sync job failed, the deployment failed, and therefore some action should be taken based upon that. That can go to a person or some sort of automated process to roll it back or whatever you feel is best there. But it's a way of integrating some post-deployment checks into the system, into your GitOps workflows.
Yeah, I this was a good insight that I got. I'll post a link here in the comments, that I wrote a blog post around pre-sync and post-sync after I had the discussion that you showed me this on, that the application can be like a pod could be running, right? It could be healthy, but it's how functional it is with the ecosystem that it needs to attach to in terms of the fleet. So at scale, you cannot have individual checks, right? You have to every component needs to emit its metrics to Prometheus, for example, using Prometheus, and then using the posting hook or part of the posting hook as integration test individually, or for every Argo CD app individually, checking is this app actually healthy, right? Completely healthy, or if there's something wrong with it. And then also in the pre-check, it's like, should I continue to deploy this thing if there's an event or SAP1 or something happening, or maybe a bake is not done yet, or the soak time is not done yet. And so I took those insights that we gave in another presentation, and I wrote that blog post, because not a lot of people are aware of post sync and pre-sync hooks in Argo CD, and that's a way of distributing, right? Individually distributing, that you were saying, not relying on a central thing watching over like 50,000 55,000 Argo CD apps, but every individually having a small test for its components.
Yeah, it also allows us, since they are just metrics, to dashboard the results of the last time that they failed and how long they've been failing for. So I know we're getting close to time here, so I am going to go really quick on this next little bit. And let's see a PR in action. So I have a FluentBit PR that I actually need to deploy today. So this is actually a real PR that needs to be done. So if we real quick
Can
here.
you show the file change?
Yeah. So right now,
window?
this
Okay.
daemon set on this particular cluster is running this version
The
of
image.
the image, FluentBit 2.0.11. All right, so I want to merge this PR. As you can see, it's got the LGTMs from a couple people. So I'm going to go ahead and say approve.
And that's triggering Pro, right?
That's
Prowl.
green Prowl. So in a moment here, Prowl's going to say, it's going to give its thing. So we just need to do
And
it.
you're just changing the values.yaml of a Helm chart?
No, so what this is doing, this particular PR is changing, we talked about the versions of stuff. So this is changing. So for this particular cluster selector, this is stage in the maintenance group A in Canary, not
Can
V.
you zoom in a little bit? Can you make it a little bit bigger for those folks?
Sorry about that.
So this is Carlos YAML file that he gave you a cluster.yaml, all right,
So
definition
this is the FluentBit app set.
for FluentBit. Okay.
for that, and it's saying, okay, I'm selecting the stage, the environment, the clusters that are environment stage, that are in maintenance group A or Canary, that are not V clusters. And we can do a whole nother talk on V cluster and the way we use it. Um, Previously, it was version 0.1.39 of the Helm chart, and now we're going to go to version 0.2.0 of the Helm chart.
I know the application set will propagate that change across all the apps that is
All,
managing that this application
all the
set.
apps and clusters that match these labels across the entire fleet of clusters. So let's see, where is this at? So you see it now has the approved label, added that. So in a moment here, Prow will merge it. But if we take a quick look back to the slide, this is going to go to 24 clusters, which will happen here in just a momento. Um, Nothing like live demos.
And like, a question is like, if when does this change get into production? Like, do we need to call our manager here to get us approval, or what type
Nope.
of QA happens process wise to get into production?
So, we trust our engineers. So I am on the so
Well, you're trusting the posting hook, right? When Fluentbit goes to the new version, posting hook and all the testing will make sure that that new version of Fluentbit is working, right? So if
yeah,
there's no red flags in staging or canary, then we're good to move to the next stage.
yeah. So there with Proud, there's an owner's file, and those owners are the people that are allowed to um, approve PRs to be merged to trigger the deployments, creation of the package town charts or deployments or whatever it happens to be. I'm one of them, so since I am one of them, I was able to add the /approve, and that's what gave it the approved label. If I wasn't in this list, I'd have to have somebody else do it. This particular one I am, so no problem. Of course, this is taking it. So there we go. They merged. Great.
So who
So
merged that? Probot, the
Prow
Pro?
merged it. Prow merged the
Yep.
commit into it 1 minute ago. It just didn't refresh. So here's our
And
list.
that's one tenant, right? A lot of companies have that. No humans are the ones merging. They're
Correct.
like approving and looks good to me, but there's no a human involved of like merging it, right? Once the qualifications, whatever they are, the system or the bot will merge it.
Yes, we effectively. I mean, we have more regions of developers in this, but we essentially have 3 different geographical regions where we have developers on the infrastructure team. U.S., EMEA, and APAC. We have 2 people in every region that could do a manual merge, just in case like Prow is failing or whatever. So we do have an override on that, but most of the engineers, do not have that permission. And so what we'll see here in a moment is all of these uh, application sets. Now, here's all the Fluentbit application sets on this one particular Argo CD are going to suddenly switch from being green to switch to being out of sync.
And this is because you have auto sync enabled in the Argo apps.
Correct. Yes. So where does it
And
show us?
do you change the resync periods of the default 3 minutes?
Yes. So we actually set the sync period to 4 hours, I believe it is.
But
Um,
this change was triggered through a webhook.
Webhook. So everything goes through a webhook. The webhook then triggers the individual ones. Um, and so we use the webhooks to do the triggering. Um, and then once the webhook triggers, everything goes through. It triggers the refreshes and goes from there. And that's because, again, we have hundreds and we have thousands and thousands of things. If we were to do a refresh every 3 minutes, that's a lot of activity to our artifactory. That's a lot of activity um, to our Git repos and all that kind of fun stuff. Here we go. All right, out of sync. If I refresh this page, whoops,
Yeah, and
button.
kind of a best practice. Like we tell folks to do an event trigger. Like it's better to using Argo CD, a webhook that it tells the Argo CD when it's time to sync versus making Argo CD compare and reconcile so many objects.
Yeah. So as you can see here, the sync has started. And so it's doing the thing. So I know we are basically at time. I don't know if you want to continue going through this or not.
So
How do
yeah,
you?
I think we'll have I think we can pick up one question.
Yeah,
I saw one question on the comments. So other like that. This is the process. Like a lot of people are aware because they're already doing it this way. But I think a lot of people are not aware that this is a using application sets, using the generators, using pull requests, no human intervention, and using something like Pro. Right? It doesn't have to be Pro, right? People can start with some. Now you have GitHub Actions. Like I
yeah.
mentioned, Pro was
You have
created before
actions.
GitHub Actions, but some system that actually tests that it's okay to merge the pull request, right? There's no typos, syntax highlighting, do a Helm test, also could be done, and then the pre and post sync hooks are something that is your guardrails. Like, but if you have them, even if something gets merged, it would not. Maybe the pre-check would not allow it to sync. So I
Right.
think that was good. I don't know if Uri can pick up a question. There's a question that says here is how any issues with Kube API client side rate limits your ACK controllers? Are you managing all ACK CRDs on a single cluster?
Yeah. So yes, 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 no. So yes, there are definitely concerns with API server load, number of resources. We run the Argo CDs in different namespaces and have it only watch that particular namespace, so we don't do the cluster scoped Argo CD on the management clusters. That way, there it doesn't get there. It's still, you know, if you have too many on there, it still creates a lot of activity to the API server and the etcd. Same thing with the ACK controllers, doing that. You definitely want to run more than one management cluster for a fleet our size, and even for smaller ones, because you want to have isolation between your non-prod and your prod at the very least, because you want to be able to say, okay, I'm going from version 1.2.3 to 1.3.0 of one of these controllers and be able to test it in the non-prod environment. You never know if you have a edge case that the upstream controller just didn't test for, right? We ran into a situation where we set a value to a null value, and it caused a crash loop back off in one of the controllers, thinking that, oh, hey, you could set it to null instead of an empty string. The controller just didn't check for that. And if we'd done that in the production instead of in the test environment, things would have just straight up blown up.
Yeah,
So,
that's what I've seen. Like sharding strategy, right? Like you don't sandbox, dev, stage, and even different prod management controllers, right?
yeah,
Where you have like, but because this is a push model, I think there's referring to you have an ACK controller like in one place and creating VPCs everywhere. So regional prod and canaries, and also you can always not always like you always have to measure and adjust, right? All these controllers have tuning. Actually, Adobe gave a great presentation in the last GitOpsCon in Vancouver, I think it was. No, in Seattle. Um, that it gave all the tuning that they do to Argo CD from like compression of Redis, how long do they do the resync, how many processors, the charting. So the same thing happens on ACK. You can adjust how often do you go back and reconcile, which not that be that often, right? That you change subnets or change that information, but one controller is pushing those changes when you deploy new clusters.
Yep.
So that's a good question. And there's many talks around there, but yeah, always go and read the documentation, and there's always going to be parameters to adjust this Kubernetes controllers APIs. It doesn't matter if it's ICK or CAPI or Argo CD. At the end of the day, all of them are reconcilers hitting the Kube API server and getting that information from SCD. Um, so that's the recommendation at scale. And like Mike said, they don't have like one huge mothership that they have all eggs in one basket, right? They have to shard it in a way to be able to scale and also limit the blast radius.
Yeah. And just so you know, here's an example of those the metric checks coming through. You can see that,
I
one
don't know if
particular.
Uri can put the mic screen up.
Oh, you don't have to. I just was showing the query. It's in the screenshot of the thing. I was just showing it live, so no worries.
Yeah. So this is like the pulse sync.
This is the post sync hook. Just one of the, one pod here is having problems from Fluent Bit, and so it's right now the job has not successfully deployed yet on this particular one, and so it's going through retries. It's going to retry again here in 64 seconds to see if it did end up recovering before it decides that it's going to fail or pass. So just
And
anyway.
this will run every time you sync, even if you do a Argo CD sync, this post sync will run again.
Mm-hmm.
So you can have the sync happening periodically and
Yep.
running again and check. So this is like live testing, I guess. You're always testing that the systems are healthy.
Yep.
So with that, I think we are out of time. Mike, appreciate you joining us today. I know we're at the end of the year; people are going to vacation, but I appreciate that you were able to join us today to talk about fleet management at scale, multi-cloud on premise, so many clusters, and how to manage that with Argo CD. Basically, Kubernetes controllers, Argo CD, our workflows. We touch on CAPI, we touch on ACK and ASO. If you want to learn more, follow Mike on LinkedIn. He'll be posting information there. I also post from the Canoe project, and we always are around in Argo City, in CNCF. If you have any questions, so thank you, Mike, and thank you everyone that joined today, and those that ask questions. So we'll see you next week for another episode. See you, folks.
Have a great holiday, everyone.
Happy holidays.